Now students, we have already come towards the end of these oscillations. Okay, we are concluding it with some other examples of SHM. I am just telling you, in syllabus it is not directly written these situations, but since in NCERT and in competitive examinations these are asked, so I am doing it. So you will see the situation and accordingly you will do. Right, but these situations are very important from other examination point of view. Look, some other examples. Number one, I have drawn figures for all the situations. Now one by one I will be describing these. Number one, oscillations of a liquid in a U-tube. Actually, you must be knowing in chemistry there is a device, there is an apparatus called a U-tube. U-tube is very much is used there in chemistry. It is a glass tube of U shape, of uniform cross section. Suppose I say capital A is the cross sectional area of the tube, cross section. Okay, that is uniform. Now, what is the situation? Let us say. Let us consider that a liquid is filled up in the U-tube under the equilibrium condition. What will happen? In both the limbs, in both the arms, okay, the liquid will be standing at the same level. That level is called equilibrium level, which I have marked. Let us say initially the liquid was standing at this equilibrium level. After that, what happens? Suppose in the left limb, the liquid is pressed down by Y. Obviously, what will happen? The liquid level in the right limb will also move up by Y. Okay? Then, in between these two levels, finally, what is the difference in these two levels? Final difference between these two levels. Initially, both the levels were at the same. But now the level difference is what? It is by 2y. Fine? It is by 2y. I have marked it. Suppose, now I describe the situation. Suppose the liquid in the left limb is pressed down and released. Okay. Placed and released to itself. What will happen? The liquid level will like this. It will oscillate. The liquid level will oscillate like this and it will always try to move toward its mean position. क्या होगा? ये liquid level, it will try to go to its equilibrium position downward. This will try to move to its equilibrium position upward. But first I have to prove, like all the situations, like other situations, that the motion of the liquid in the U-tube is SHM. That will be our first objective. So, if I ask you why the liquid is coming to its own equilibrium position due to which force, your answer will be restoring force. Restoring force will be there due to how much liquid of column what? Obviously, it is due to the liquid of column twice y. ये y और ये y दोनों का. इसका मतलब क्या हुआ? हम लोग क्या लिखेंगे? Restoring force F is equal to weight of the liquid column of length twice y. Weight of the it is due to the weight of the liquid column of the length twice y. इस twice y length वाले liquid के चलते ही restoring force लग रहा है. ठीक है? इसका मतलब क्या हो जाएगा? What is this? F is equal to weight of the liquid column. Weight कितना होगा? Length हुआ twice y into A. That will become the volume. Twice y into A. How much? It will become the volume of that liquid. Into rho, it becomes density and it is becoming G. ठीक है. Now as f is equal to ma, so ma is equal to, here I write minus twice y a rho g, negative sign shows liquid level, okay, tends to move to equilibrium position, okay, tends to move towards the equilibrium position. ये अपने इक्विलिब्रियम पोजीशन की ओर जाना चाहेगा, इसलिए नेगेटिव साइन उसी का सिंबल को शो कर रहा है. इसलिए मैं क्या लिखूंगा, a is equal to minus twice a rho g by m, okay, into y. Look, what is m? M is the mass of liquid in U-tube. That means this bracket term is a constant. Look, everything is constant. So A is directly proportional to minus y. So the motion is SHM. I hope you understood. This bracket term will be a constant. That means by SHM, what we can say, omega square is equal to twice a rho g by m. And what is this? Omega is equal to root twice a rho g by m. So t is equal to 2 pi root m by twice a rho g. That can be written. And what is m? M is the mass of the liquid column. I will write here twice pi root over m. m की जगह पर क्या लिखें? m will be equal to how much? m will be equal to a into, look, if I consider capital L, look here, length of the liquid column in the tube. Since capital L is the length of the liquid column in the tube, then L rho by twice a rho g. यहाँ से a and rho cancel हो जाएगा. That's why finally I am writing the expression here. T is equal to twice pi root L by twice g. Here, what is L? L is the length of liquid column in the tube. Length of liquid column in the tube. I am writing the final expression here. Please go through it. It is the final expression of this previous discussion. It is the final expression. Look, just you go through these all points and try to understand. This is all regarding the oscillations of a liquid in a U-tube. Now, this is the first situation. Now, I am discussing the second situation. I start the second situation from here. Look at this. Oscillations of a body dropped in a tunnel along the diameter of the earth. Look, this is, just try to understand the situation. In the situation, this is the earth. In the earth, a tunnel is dug through the center of the earth. A tunnel is dug through the center of the earth like this, as shown in the figure. It is the tunnel that is dug. Radius of the earth, this is the center of the earth. Capital R is the radius of the earth as usual. P is any point, okay, whose distance from O is y. Its depth from the surface is d. I hope it is very clear. Here, R is the radius of the earth. and d is the depth of P. Obviously, depth is always taken from the surface, so depth. The situation, try to understand. The situation is, suppose a body, okay, is dropped in through this tunnel. Then it says that when it is coming to a point P, any point P, it will start oscillating SHM. It will start oscillating SHM. This is the situation. The situation is this, that when this body is coming to the point P, it starts oscillating, okay, starts executing rather SHM. That I have to prove. Now, how to prove it? यहाँ पर क्या होगा? यहाँ पर मैं लिखूंगा acceleration due to gravity at P will be, we know, G dash G into 1 minus d by r. I hope all of you remember, in gravitation we have already done it. Then it is equal to G into r minus d by r. G into r minus d by r. R minus d, just you see, G dash equal to G into y by r. Here, I write here r minus d equal to y. And I put a negative sign because the body tends to move towards the mean position. Okay, negative sign shows that the body tends to move to its mean position. I write tends to move to its mean position. Then what will happen here? Obviously, here G dash will be directly proportional to minus y, means SHM, because small g and r both are constant. So omega square is equal to G by R, which implies omega is equal to root G by R, which implies T is equal to twice by root R by G. This is the final expression. Our final expression here is this. T is equal to, that means we have proved that the body will start moving, it will be doing the SHM, it will be executing SHM, and the time period of SHM will be twice by root R by G. यही हो गया इसका एक्सप्रेशन. ध्यान रहे ऐसी स्थिति में. I hope you got this point also very clearly. And now in the next lecture I am going to discuss the third situation. The third situation is shown here. I will show you, I will discuss the third situation. Okay.